not quite sure why my OBS keeps crashing. I'm going to work on trying to bring you this in a slightly different way. And here's to hoping I don't crash OBS anymore. There. So let me resize this onto the screen. We just had the second stage engine cutoff. I'm resizing this to bring it to you. Again, so many apologies for the technical difficulty. I am not at all sure why my OBS decided it is determined to crash. Okay, let me change that. There, so we are back together. So what they're doing is they're getting ready to launch the 2 GRACE spacecraft.
So we are looking for second engine cutoff and a signal for second engine.
So they're talking about a loss of signal. Let me see if I can get the audio back into this for you.
Pushing communications over McMurdo.
Will we be able to actually see the satellites deploy?
There's a good view, actually. We're hoping that we'll be able to get a glimpse of the GRACE follow-on.
So we should have the spacecraft flying off now.
The deployment of the GRACE follow-on spacecraft was deployed. That's confirmed, deployed successfully.
Fantastic. And you see the excitement in the rooms here.
Yes.
We could hear them.
Yes.
Thanks, Paranor. That's interesting news.
That is the EMOC at JPL.
Yeah.
We have folks here in the MDC, here at Vandenberg Air Force Base. So far,
that
so
is
good.
About the least exciting launch group I've seen.
Now the second stage of the launch vehicle continues on to deploy the Iridium satellites.
It's got more work to do.
It does, and we wish them the best of luck for that.
All right, deployment of the 5
I'm guessing
Iridium
that
satellites.
they've just had a very long day.
So now we have to wait for the satellite, the GRACE follow-on spacecraft to stabilize.
So they're now flying up to 500 miles.
And
so this is a very weird launch. So I'm hearing that they're waiting for the GRACE satellites to stabilize.
So we have confirmation that both GRACE satellites have indeed been
correct.
deployed.
Both GRACE follow-on satellites or spacecraft were deployed successfully, and now the spacecraft will be stabilizing.
I love all those apples
in their orbit. They'll be getting away from each other. That's natural movement that we intended for the spacecraft to do.
They must be waiting for something, because those people do not look nearly as bouncy as I would have expected, or they're just more tired than I would have expected.
We will know exactly what altitude they're in and what additional adjustments may need to take place. However, the spacecraft, in the mode that they come on, once they're released, they're in the safe mode, so the solar arrays face the sun, and the antenna faces Earth.
So they're going to be flying over the South Pole and communicating down with the science station on the South Pole.
So things are looking good.
So I'm going to switch and see if we have better feed coming in, or at least a more interesting feed coming in from SpaceX at this point. So let me check the other station on this launch. So this is SpaceX. Let me embiggen this. So in just a moment, I will have the SpaceX feed for you. I just need to switch between the two different setups. Okay, so here we are. This is the SpaceX feed that you're now seeing. And it shows you where the different stages are and where we are in the continued launch of this Falcon 9 as it deploys the Grace follow-on mission. It just finished that. We're now waiting for the spacecraft to fly over Antarctica and check in with us. And the rocket itself is heading up to a higher orbit at 500 miles above the planet, where it will begin deploying the Iridium satellites. These are communication satellites. If you guys have any questions, I am happy to try and answer them. I'm also going to work on getting the audio from this particular feed so that I can hear it as well. Oh, shoot, I turned on the wrong thing. Sorry. There you go. So it's currently a boring video from SpaceX, but this is what I was aiming for. It's true. So what Guido is referring to in the chat is it used to be that the Iridium satellites that were launched in the late 90s and the early 2000s, they broke some rules, you might say. So it was discovered after they launched that they were transmitting in parts of the radio frequency spectrum that, while useful for satellite phones, are more useful for radio astronomy. These are parts of the radio frequency spectrum that we had set aside to be used for radio astronomy. And after launch of the original Iridiums, it was discovered that the satellites were broadcasting exactly where astronomers were trying to observe the night sky. So that was one problem, but despite having that problem, they also had one amazing side benefit. And that particular side benefit was their solar panels were just right to catch the sunlight and send it back to Earth with the most amazing bright sparks across the sky. But not literal sparks, that's probably a bad word to use. They reflected the sunlight back in such a way that you'd get this amazing flash and fade away. So I'm working. Okay, so there's no audio really currently on the SpaceX channel. I will flip back over to that as soon as I have more information. So Michael, yeah, minus 3.9, that's like brighter than anything natural occurring in the sky other than the sun or the moon. So the old Iridiums were kind of amazing. So Larry, I understand wishing that they still had a camera, but yeah, you can't always get what you wish for. So let me pull up a timeline and find out just how much longer we have to go. So for those of you who came over here from the Skyliest channel, welcome. I'm Dr. Pamela Gay, and you have found yourselves at CosmoQuest. At cosmoquest.org, we invite you to help us explore our planet and the cosmos beyond. We're actually a citizen science site, and we have a variety of different projects online that can allow you to map out the Earth and map out Mars, Mercury, Vesta rather. And each of these unique surfaces offers us different science that we can accomplish. If you'd like to be working on doing Earth science while we wait for these Earth satellites to finish their deployment, click on over to cosmoquest.org, and there's a whole lineup of different projects that you can work on. Now, while we're waiting, however long, for this to take place, for it to get to the next stage in the mission, I'm going to go ahead and just pull up one of our CosmoQuest projects. Now, as I said, at any point you are welcome to ask me any questions you may have. My day-to-day job is I'm the Director of Technology and Citizen Science for the Astronomical Society of the Pacific. We're a 501c3 nonprofit dedicated to putting science in your brain. So if you want science in your brain, give this channel a follow and we'll do everything we can to help you learn and do science. Now, what I'm going to pull up is our Earth Science project, which, oh, where did the audio go? There it is. Pull up our Earth Science project, which is called Image Detective. So let me switch the view again. So here at CosmoQuest, we have, as I said, Image Detective. This is a project for mapping out our own planet Earth. We also have projects to map out the Moon, Mars, Mercury, and Vesta. Now, each of these projects has you accomplishing different scientific goals. With Image Detective, we invite you to go through, and we start out with a tutorial because doing science, you can't just walk into it without any training. You don't need a PhD. In fact, for a lot of things, you don't need a PhD. But you do need to know your way around. So we start off by orienting you. And let me embiggen this. So I'm going to go into the tutorial, and it lets me pick what image taken by astronauts up on board the International Space Station I'd like to try and locate. It turns out that astronauts, just like regular everyday people, don't always label their photos. So as they send their pictures back, all of the photos that they're taking in outer space are getting stored in an archive. I'll go ahead and do that night shot. All of the photos that the astronauts are taking from the International Space Station are getting stored in an archive down at Johnson Space Center in Houston, Texas. These images, some of them contain outer space. Some of them allow us to see sea and land. And by having you go through and help us analyze these images, we're able to add metadata to them that will in the future allow them to be used by scientists who are studying everything from urban sprawl to changing sea traffic. And there's also, because the astronauts like to do their own astrophotography, there's a few pictures in here that the astronauts have taken of things like the moon and the sky beyond. So here I am, I'm trying to identify what's in this particular image. It has a river. I don't really see a coastline. It's night, so I can't tell a whole lot. I don't see any of those things. So this is, in this case, all I have to do to try and help make this more useful for science. I just click through and it teaches me what's necessary. Now, rather than watch this video, I'm gonna go on and just work on trying to solve this problem. Now, looking at this, I can see I have a city and I can adjust the transparency, and my goal is to try and find that city on this map. Now, all I know is this is a pretty big city. And what I'm looking at here, so I have a tiny blue circle in the center. And that, let me go ahead and cover all of the screen with this for a moment. So this blue circle in the center, that's what was directly below the International Space Station at the moment that this photo was taken. My goal is to line that photo up with something in the astronaut's field of view. I'm just going to make a wild guess that maybe that big city was this big city of Paris. So I'm going to use Google Maps to go ahead and zoom in on this and see if there's an island like that on the river in Paris. And yeah, it looks like there is. I can see there's this little island down here. I'm going to turn all the labels off because they're cluttering that map up. So here I see islands like what I saw in that original photo. Maybe. Not entirely sure. Nope, that's not quite the islands I was looking at. Let me zoom back out. See if there's other islands in Paris. And I may be wrong, this might not be Paris. There's a lot of different things out there to consider. Okay, I'm thinking I picked the wrong city. Now, this isn't an easy project. It's one that really requires you to take a Where's Waldo approach on the planet and try and understand all the different things that astronauts might want to take pictures of. Now, I do know I'm looking for a fairly big city. I'm going to try Nantes as my next guess, just to see if it also has a river running through it. Now we're continuing to wait for something interesting to happen. Here we go. Here's another city with another island in the river. And this looks like it might be closer to right, because I see here's this flowy bit over here. Let me bring my photo back up. Maybe not. I'm not sure. So as I said, this is a hard game of where in the world is the thing I'm looking at. I'm going to bring the transparency back up on that. So this could be it. So I see the two roads. There's another road, another road. So I think I might have found it, but I definitely zoomed in too far. If I flip the map out of satellite view, it's true. I will have better, but if I'm trying to line up on the actual geographic features, I think this is just a little bit easier. I'm looking to see. So Michael brought up some sort of an interesting, I'm going backwards through the chat to try and figure out what you're talking about. So KFP, what was your question? Yes, Michael, spacecraft do definitely have air in them and air resistance, but it's fairly minor. So I'm going to flip back over to our SpaceX and see how the spacecraft is continuing its journey up to 500 miles. For the continued deployment, oh, we still have a ways to go. For the continued deployment of our spacecraft. So this is what I'm seeing on the SpaceX coverage. We are T plus 29 minutes, 10 seconds from takeoff. And this is the boring part of every mission. So I'm going to try and see if I can catch up with what's going on in the chat. And as I said before, feel free to send me any questions you may have, and I'll do my best to answer them. Okay, so KFP is asking about the difficulty to turn a wheel on Earth. Now, this is a complicated question because I don't know what all is going into turning the wheel. Are you talking about like just a big heavy wheel on an axis that isn't touching a road? So just for the sake, I'm going to use the lid from my lunch as an example. So here I have something with a little bit of cilantro on it. So let's say I have this wheel and it's on an axis suspended in a room and it's not touching any surface, so there's no friction involved. And what I want to do is get it rotating. Now, on the planet Earth, to get it rotating, since gravity is neither here nor there in getting the wheel turning, what I'm trying to do is overcome its momentum. I'm trying to get it from being an object at rest that wants to stay at rest to an object in motion rotating around that axis. Now, on Earth, I basically have to dig my feet in, plant myself solidly, and then try and find some handholds on that wheel and use all my force to get it rotating. In outer space, I'm in a bit more of a logjam, because if this is a big heavy wheel and I'm on a spacecraft, what is actually going to happen is I'm going to get the wheel rotating one direction and the spacecraft rotating the other, unless it's somehow using rockets or something to hold itself in place. So there's that minor problem, that for every reaction there is an equal and opposite reaction, and in this case there's an equal and opposite conservation of angular momentum. Now, the way to think about these things in general is I exert a force to move a mass. A mass is how many atoms is in the object. It is how many atomic units each of those atoms has that adds up to the total mass of this object. Now, here on the planet Earth, when I hold my phone, gravity holds my phone onto my hand. Gravity is pulling down, it's exerting a force on my phone. Now, luckily, the atoms in my hand are chemically bonded together, and my hand isn't letting the phone pass through it. Now, in space, you don't have gravity holding things down. So, when we're trying to figure out how much mass something has, Astro Helge, that's a long timeline. Yes, Michael, a big wheel at an amusement park, that's kind of what I was thinking. So here I have gravity holding my phone. And let's say I want to push it this direction. Now, if the only direction I'm moving it in is perpendicular to gravity, then what's holding it on my hand is gravity. But to move it, I have to exert a force that moves this amount of mass. And the force I have to use to push it this way, on Earth with gravity and in space without gravity, is the exact same amount of force. Because what I'm trying to overcome is friction, not gravity. Now, since we live on the surface of a planet, we often confuse gravity and it creating weight. Weight is how our muscles perceive gravity pulling us down towards the planet. It's how our skin perceives leaning on the arm of a chair. So this is unfortunately something that causes us to get confused when we talk about weightlessness. What that means is, in space, if you try and lean on a chair, you're actually going to end up bouncing off because you're the one exerting the force on the chair. Now, with our big wheel, all I'm trying to do is overcome its momentum. I'm trying to exert a force that gets the wheel turning. And gravity has absolutely nothing to do with it in this particular case. I don't know if that helped at all, but as I was saying, the force needed to get this wheel turning in space is the same force as you need here on Earth to get it spinning, assuming all the frictions in the system stay the same. Now, we do have a good long time, about 20 more minutes before the next stage, and it appears that we probably won't get any interesting information when that happens because they didn't stick a camera on it. At this point, I'm tempted to get back to work and do a follow-up on how this is going with another stream this evening. So over here at CosmoQuest, we do a variety of different shows throughout the day and the week. Monday through Friday at 1 p.m. Eastern, which is 10 a.m. Pacific and 6 p.m. London, we present the Daily Space, which is a quick roundup of all of the news from space and astronomy brought to you in a quick pack, fast-paced bundle. Then on Tuesday nights at 9 p.m. Eastern, which is 6 p.m. Pacific and 11 a.m. Wednesday in Sydney, I bring you my astronomy office hours where I'm working on doing coding simulations and answering any questions you may have. So I'll be back on the air in, about 4.5 hours, and I can bring you a conclusion of how well this mission did or didn't proceed. But all is looking good, and in fact, all is looking nominal. And that's all you need to be if you're a spacecraft. I see KFP as another question. Does gravity have the same speed as light? As far as we know, gravity does travel at the same speed of light. There's been a number of different experiments done that unfortunately do have a fair amount of error in them, but all the measurements are consistent with gravity moving at the speed of light. And that does mean that it would take roughly 8 minutes were our sun to suddenly get yanked into an alternative reality for our Earth's orbit to change because there is no longer a sun pulling on it to keep its orbit, orbiting. So I'm looking to see if there's any other questions. There's so much of science is hard to test. So welcome to everyone who's new. Thank you so much for all the follows. And I hope I get to see you more and more here on this station. And whenever there's a launch at a reasonable hour, we will work to bring it to you live here at CosmoQuest on Twitch. Again, this is CosmoQuest. We are part of the Astronomical Society of the Pacific, a 501c nonprofit that works to put science in your brains. Thanks a lot. Bye-bye.